Hi, I'm Shuragna Datta. Today I'm discussing about the physics chapter, gravitation. Firstly, we all know about the gravity for which we are always attracted towards the center of the earth. And we also know that gravitation is invented by Sir Isaac Newton and also the famous story with that apple. So I firstly said that the definition. Gravitation is basically a force, and more precisely, it is an attractive force. So we can say by a single sentence that gravitation is a force which is act between the two body with masses. But this force also depends on some factors, that is mass, distance, and other things. Then firstly, we go to the first slide and we can see that the force is directly proportional to the product of the mass of the object. And second one is the force is inversely proportional to the square of the distance. So if we go to the mathematical formula, then we have to go for this second slide, 1 second, and here it is. So we can see that the Fg, which is a gravitational force, here we use the suffix g to indicate it as a gravitational force, nothing else, which is equals to the capital G, where capital G is the universal gravitational constant. M1, M2 are the masses of two objects in the figure, that is M1 and that is M2. And R is the distance between the two objects. So combining all the forces, combine all the things, we can say that Fg is equals to capital G, M1, M2 divided by R square, where I say previous that G is the universal gravitational constant. We always should remember that it is a universal gravitational constant. So the value of G is always fixed and the value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So now by the formula, we can say that as the mass increases, the gravitational force also increases as it is directly proportional with the force. And if the distances increases, then the force will be reduced as it is inversely proportional. So when two huge amount of mass bodies are equal, are nearly equal, then there are huge gravitational attractive force act. And if they are separated by large distance, then the gravitational force just reduces. That's why we can also say that gravitational is a short range force or a weak force. Now, if we discuss the chapter more, then we also get some more other things, that is gravitational acceleration, by which a free fall body are accelerated. And we all know that the free fall means where no other force are act without the gravitational force, and that value is, we also read that by Newton's law, F equals to ma, where m is the mass of the body and a is the acceleration of the body. But for the free fall body, that a is converted into small g, which is gravitational acceleration, and the value of that g is 980 centimeter per second square or 9.8 meter per second square. That g vary with the height and the depth from the earth's surface, and that's the other thing. But we should always remember this formula, that is F equals to G m1 m2 by r square, by which we can solve all the numerical formulas and all the numerical methods of gravitational chapters. So here we should remember 2 or 3 things, that gravitational force is invented by Sir Isaac Newton. It is an attractive force. The force mathematical formula, that is, I repeat thrice, G m1 m2 by r square. And we should hear the today's class that is based on that formula. And here is the thing, we can solve all the numerical problems by this formula, and try to remember the G values, that is 6.67 into 10 to the power minus 11 I told previous. So here is the today's class. I think I'm done with that 2 slide. So thank you. I think that is enough for this chapter, and in later we can also discuss the more of the things, that is small g, how it vary with the other things, and how g vary with the density of the body and all the things. But for in short, these things is enough, we always should also remember that gravitation is an attractive force. There is no repulsive force. Always two bodies are attracted each other. There is no repulsion between the two bodies. We always should remember this. So here's the today's class, and thank you. Have a great day.